Hello everyone, and welcome to the NEATEC Electronics Series. This video is about state machines, so let's get started. Alright everyone, welcome back. Alright, so starting with our counter video. That was a few videos back. If you recall, I said that a counter is a type of a state machine, okay? So now what we're doing is we're broadening your view here, okay? So I'm going to go back, don't worry, I don't expect you to remember everything from the counters. So if you think about what you did in counters, all right, and we're going to use what you learned there, and we're going to expand it a little bit, okay? And it becomes much more usable. When you understand state machines, you literally can make a digital circuit to really do almost any kind of logic you want. All right, it's pretty fantastic. It's a very good tool to have in your tool belt here. Okay, so first there's two types, the Moore and the Mealy. The Moore type of state machine, the output is determined by sequence. The Mealy, the output is determined by sequence and logic. And this is where it gets really interesting, okay? Because then you can have multiple outputs that do many different things, okay? This is rather fun. But we're going to start with the Moore machine first. All right? So I don't know if you've heard of this before. There is something called gray code. Alright? Now gray code, and I'm going to draw it for you right here, is Q0. Here's Q1. And here is Q2. Now you can read on this. This is used in shaft encoders to help determine how a rotary item has rotated, right, where it's located. But what we're interested in, this is not a class or not a video on gray code. It's pretty fascinating though. But let's just draw it. Or write it down, I'm sorry. 0, 0, 0. So each bit, we're starting with a 0. Now we're only going to change one bit at a time, okay? This is kind of like when you're making a Karnaugh map, if you recall. You only changed one bit. Well, here we're doing the same thing. So we're going to change a Q0 bit to a 1. Okay? Next one. We'll keep that. We're going to change a Q1 bit to a 1, right? And we're going to turn off your Q0 bit. Now that's the first 4, isn't it? Okay. Now we're going to start modifying Q2. Just changed that one, didn't we? There we just changed Q0, get it? Here we're going to change Q1. Okay. And we're going to change Q0 again. 1. Okay. Now there you go. There are 8 unique states here, okay? Now, if you recall, the next thing you're supposed to do once you have your sequence down is you're supposed to draw a state diagram. If you recall that from the counters video, right? Okay, so for the counters, let's draw it, shall we? We're going to have state 0, and that's going to be what? 0, 0, 0, right? Here's the next one. Here's your state 1. 1, 0, 0. Here's your state 2. I'm following these down here, by the way. That's your state 0, this is state 1, this is state 2. Now we're going to work on this one right here. This is state 3. So we'll bring it right down here. Okay? And what's that one going to be? It's the fourth one. It's going to be... Got that right? Okay. Now we're going to go to state 4. Okay. Now that's going to be what? 0, 1, 1, right? That's this one, isn't it? Now we're going to go to state 5. And that's going to be 1, 1, 1. Then we're going to go to state 6. Come on, there we go. State 6. That's going to be 1, 0, 1. And then we're going to state 7. What's state 7 going to be? And then it's back. Now, do you recall what you have to do with each one of these? We make a bubble or a circle. These aren't very round, but I'm doing the best I can. Okay, so you draw one around each one here. Got it? Alright, what are we missing? The arrows, right? Because you're going to go here, 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 here. Your state is determined by the sequence, isn't it here, right? This is a Moore type machine, right? It's simply, it just progresses around, right? Okay, so now I'm going to have to clean this up a little bit to get more space, because the next thing we have to do is create a state table. Okay, everyone, give me a minute. I'll be right back. All right, everyone, I'm back. And I've just filled in your state table. And let's go over it, shall we? So let me just, it's your state table. So if you recall, here's your gray code, all right over here. Then we drew the state diagram right here, all right? And now we're talking about your state table, which is right here. So this is your present state, okay? And this, if you notice, this is important, okay? Notice the order this is written. It's in your standard binary. Here, this is 0, right here, right? Then we went 1, this is 2, 3, 4, and so on all the way down to 7. Okay? Got it? It's not written in the order of your gray code. It's not written in that order. We write the present state in a standard normal way for binary that you already know. Now, based on this value in your present state, you notice it's 0, 0, 0, for example. What's the next state? So we'll come over here, and we're going from here to here, aren't we? So the next state is 1, 0, 0, which is what we have here, which is when now I'm looking at this one. If you look, it's 1, 0, 0. Got it? Now, for example, now let's go to the next state. You're at 1, 0, 0, which means you're right here. Now you go into this one, which is going to be what? 1, 1, 0, right? So if you look here, the next state is 1, 1, 0. Got it? I'm using your gray code table here. I could have just as easily used your diagram. It gives the same information. Notice 0, 0, 0 here in state 0, which is right here. And if we're looking now at state 1, it goes to 1, 0, 0. Well, it's the same thing. Get it? So based on your present state, which you wrote down in normal binary, refer to either your state diagram or your initial table to get what the next state is, all right? So that filled out both the present column and the next column, okay? Now, depending what you're going to use to make your state machine is going to make a difference on this synchronous input column, okay? We are going to use D flip-flops. Remember, we also used JK flip-flops. You can use either ones, it doesn't really matter. But you need a table. So if we're using a D flip-flop, I'll write it down here, D flip-flop, right? So let's look at the input. If this is D, we look at your Q value, right? If D is 0 and you clock it, what's Q? It's 0, isn't it? If D is 1 and you clock it, what's Q? 1. Remember, Q follows D, right? So for each one of these, let's start at Q0. Q0, right here, we're going from a 0 for present state to a 1 for the next state. So you're going from a 0 to a 1, okay? So that means that your D value must be a 1 when you clock it, right? Because if you look here, okay, D has to be a 1 when you clock it for the Q to be 1. Actually, I think we wrote this in a different way. If you went from 0 to 0, 0 to 1, 1 to 0, and 1 to 1, right? This is your transition for your Q starting and your Q finishing here, right? Your D has to be whatever your final Q value is, right? Because when you clock it, as we said here, your Q value is going to take on whatever D is, because Q follows D. You may notice that the sync inputs, this whole table is an exact copy of the next table input, right here, okay? And that's why. If you have any questions, refer back to your flip-flop video, okay? Because we went through both of these. But we used the D flip-flops really to make it simpler. But just remember, with the D flip-flop, the rule is Q follows D. So whatever D is, when you clock it, that's what Q is going to be. Okay? So obviously, if you want an output here to be a 1 for Q naught, that means D has to be a 1 when you clock it. Okay? So guess what? Now we have a complete table there, don't we, for your synchronous inputs? Now, we can start to draw the K-maps. And let me do this here. Everyone, I thought I could keep it. I can't keep it. I'm going to have to get rid of this state diagram, okay? I'm going to keep the state table because it takes up less space, okay? Here we go. All right, so let's draw 3 Karnaugh maps, shall we? So let's look at D0. This is going to be a 1, isn't it? Because we're looking at this column right here. I'm sorry. I was telling you the other one. We're looking at the inputs, right? It's a 1. Well, then we come over here to this one. We're at 0, 0, 0, 1. So Q naught changed to a 1, and it's a 1. So that's a 1. Remember, you use your present states when you're doing this, okay? Use your present states. So now we're on to this group right here. That's 0, 1. So those are going to be a 0, 0. Make sense? Let's do the next group, shall we? That's going to be 1, 1, isn't it? That's down here. Remember, the Karnaugh map is not written in the same order. So if you notice, 1, 1, these are both 1, right? And now we go to the 1, 0s, which is right here. And what's that going to be? It's going to be 0, 0, right? That's a 0, and that's a 0, so that's a 0, 0. Alright, so you follow the same method. Now you use D1, right? But now we're going to solve this for D1. This was, I don't think I labeled this, did I? Why did I do that? I don't know why I did that. I meant to name this. This is D2, this is D1, and this is D0. I'm sorry if that caused any confusion, folks. So now let's do D1, shall we? That means we're going to be looking at this column right here, okay? So when Q is 1 and Q2 are both 0, which means we'll be looking at this, we have 0, 1. Get it? So 0, 1. Now let's look at this right here. This is when Q1 is 1 and Q2 is 0. Right here and this, right here in this column, or not column, but row. Let's come on over and see what we get. It's going to be a what? 1, 1, isn't it? Okay, this one's going to be what? 1, 0. This will be a 0, 0. And finally, we do D2, which is this one right here. 0, 0. 1, 0. 1, 1. 0, 1. All right. Beautiful. Now we transferred what was in our state table to our Karnaugh maps, right? Remember, we have to get circuits for each one of these inputs, okay? To get the circuits, we have to draw the Karnaugh maps. Now, once we draw the Karnaugh maps, we have to solve for them, right, to get the expression, okay? So let's group them, and I am going to group the ones. If I group the ones, that means I'm going to be using SOP, right? What does that stand for? Sum of products. Okay, if you said that, congratulations, okay? So, for Q0, those ones, okay? So for those, I'm going to say for D0, I'm sorry. If I said Q0, I'm sorry, but D0 is what I meant. So let's look at those, right? So that's going to occur when, remember, this one changes in the group, Q, right? Q0 changes, so you can discard Q not and just keep Q1 and Q2, but they're both 0, right? So this is going to be Q2 bar, Q1 bar for that one, right? And then this one, the next one, I'm talking about the, I'm going to just draw this one right here. You can see where I just put that down. I'm looking at that circle right there. That's going to be Q1, Q2, right? And I'm going to have to just get a little bit more space, aren't I, here, right? How am I going to draw this? I'll draw it this way, right? So then we'll Q1.222 or Q2.Q1. And since they're ones, you don't have a bar over them, right? Each one. Got it? Okay, so that's D0. Let's do D1. So if you look at this one, I guess I can see you can too. There's one. And there's one, right? So let's solve for this one. What's this one? I'm going to use some real estate up here. It's just getting too crowded below. This one is going to be Q0 and Q2 bar, isn't it? Because Q1 changes in that grouping, right? So this is going to be Q0 Q2 bar. Make sense? And let's do this one, shall we? That's going to be, do this at home while I'm doing it here, but let's just look at this one. It's going to be Q0 not and Q2 and Q1, okay? Q0 bar and Q2 bar, right? I'm sorry, that's not Q2, that's Q1. If you recall, because it doesn't change. I looked at that too fast. Q1. It's going to be a, and you know, wait a minute. That's not a bar either. It's going to be Q1 in it. That's going to be Q1, and this will be Q0. That's a 0. 0 bar. Okay. And what did we do? We get the other one up here? Q0 and Q. Okay, looks like we're doing okay. Now let's finish with this one, shall we? Just remove that for real estate. What can we do here? We got another grouping here, don't we? We know what that is. We just did a similar grouping on the other one, and this one, that's a new one, but it shouldn't be too bad. So this one will still be Q0 bar dot Q1. Okay. And this one here, I'm gonna write it up here. That's gonna be Q2 Q0. So it's gonna be Q0 Q2, little dot in between them. Okay. So there you just did your groupings, right? And you have the expression for each grouping. So let's write them here, shall we? We call that D0. What's that going to be? It's going to be Q2 bar ended with Q1 bar. Remember, sum of products, and we're going to have an OR gate. And then what's it going to be? It's going to be Q2 Q1, right? Now let's take D1. That's going to be Q2 bar dot Q0 or Q1 dot Q0 bar, and then we got D2, right? There we are. We have Q2 dot Q0 or it's going to be Q1 dot Q0 bar. Here we go. Wow. Now this is what you were after, and that's why you had to draw your Karnaugh maps. Get it? Take your time when doing these things, because you constantly have to check yourself, because if you make one little mistake, it all messes up, okay? Alright, so give me a second. I'll be right back in a minute. I'm going to have to erase some things to give us space to draw the circuit, okay? See you in a minute. Alright everyone, so basically I got rid of the state table, as you can see, and the Karnaugh maps, and I kept our expressions right down here. I kept the gray code at the top there, and here are our expressions that we came up with. So remember, we had D0, D1, and D2, right? Or we had Q0, Q1, and Q2. So we're going to have 3 D flip-flops, okay? And that's what I've written here, D0, D1, and D2. Now obviously the clocks, I just wrote them in red, or connected them in red, and they go to a clock, all right? They're all clocked together. So the outputs are Q's, so this is going to be, at this point, what's that going to be? It's going to be Q0, this is going to be Q1, and that's going to be Q2, all right? I just connected them. Now, each one of these expressions has 2 AND gates. I'm looking right down here, okay? We have 2 AND gates, and they're ORed together. So that's why I drew 3 of these groups, okay? So for this one, I'm trying to think of what color I should use. I'll use black. Okay. We're going to come out and then we'll simply connect these together. Right? And let's do the same thing here. And then we'll do the same thing here. All right. Now let's just look at it. Okay, I just want to make sure you guys understand this part. Remember, when you look at these expressions here, you have an output for them, right? That's what this is right here for each one of these. There's your output. And for each one of these, they're going into either D0, D1, or D2. Obviously, this is D2 over here. This is D2. This is D1, and this is D0. Okay? Since you can't see me point, I just make little dots so you can see what I'm talking about. Okay? All right, let me erase these dots because I don't want to make it confusing for you in any way. So let's just look at Q0 or D0 first, shall we? That's this one right here. So we have 2 AND gates, as you can see, and an OR gate. The OR gate is already connected to D0. But let's look at what we have. We have to connect Q1 bar and Q2 bar. So let's try it. Here's your Q1 is coming right out here, isn't it? We'll hop over that. Right there, and we have to put an inverter in there, don't we? So let's just do that one right here. There's an inverter there for Q1 bar. That's this one. We got to get this one. It's Q2 bar. It's the same thing. We'll just tap off this Q2, come up, go through an inverter. There you go. Okay? Now the other one, we have to go Q1, Q2, right? Well, Q2 and Q1. There we go. So it looks like that one's all wired up, right? Let's do D1 next, shall we? So this one's going to be, if we start on the left, right, we have a Q0 and we have a Q2 bar. So your Q0 is right here. I just come up here, jump, jump. There's your Q0, right? And Q2 bar. We already have a Q2 bar, don't we, right here? We just tap off it. You know what? We don't have to do it that way. We can do it better. There you go. There's your Q0. There's your Q0. And there's your Q2 bar. Very good. Now we have to get Q1 and Q0 bar for this one. Well, here's your Q1. Right there is your Q1. Q0 bar. We can tap off this one, can't we? Just run it through an inverter. It's a little inverter there. Okay, so there's your Q0 bar, and there is your Q1. Let's do D2 now. So, for D2, we have a Q0 and a Q2. So where's your Q0? Here's your Q0. Looks like here's a Q2, right? You guys, I'm trying to keep this as neat as I can. This is rather challenging. And then finally for D2, we have a Q1 and a Q0 bar. Wait a minute, I had Q0 all the way up here, and that's Q2. Okay, that's right. And now we want to get Q1. We can take this right from here. And the other one is a Q0 bar. Let's come right off here. Go through an inverter. Put it down. Well, what do you know? There's your circuit, huh? You see how we did that now? It's really the same method that you used for your counters, all right? Except now we didn't count in a specific order. We used, well, we did. We went in a specific order, but not counting. We used this thing called gray code, right? So what did we do? We drew the table, then we drew the state table. From the state table, we drew the state, the state diagram we drew. Then from the state diagram, we made the state table based on our flip-flops and our transitions. From that, we then created Karnaugh maps. From the Karnaugh maps, we solved the Karnaugh maps. And after we solved the Karnaugh maps, we then had expressions, which we have here, and then from the expressions, we made our circuit. All right? All right, everyone. This is very good. I have one last video to briefly go over the Mealy machine. Okay? See you soon.